Hello friends, this is your cloud mender Gaurish. Today we are going to discuss some problems related to electrostatics, specifically some questions related to electric charges and Coulomb's law. So let's move on. First of all, I am going to give some formulas related to our topic, and they are Q equal to Ne, Q equal to Ne, which is from the quantization of electric charge, where the total charge of a system is the multiple of the number of particles and the elementary charge, that is E. E is equal to 1.6 multiplied by 10 raised to minus 19 Coulomb. And the second thing to be noted is the mass transferred during mass transfer during charging will be equal to the mass of the electron multiplied by the number of electrons transferred, that is n. Mass transferred during charging, okay, transferred during charging. And so let's have some formulas from the Coulomb's law also. From Coulomb's law we have the force of attraction or repulsion in vacuum that will be equal to 1 by 4 pi epsilon 0 multiplied by q1 q2 upon r square. Okay, here q1 and q2 are the charges and r is the distance between those charges. Okay, epsilon 0 is the relative the permittivity of the free space, and the whole value of this 1 by 4 pi epsilon 0 will be equal to 9 multiplied by 10 raised to 9. So the force of attraction repulsion in a particular medium will be equal to 1 by 4 pi epsilon 0 1 by 4 pi epsilon 0 multiplied by k or epsilon r. K will be the dielectric constant or the permittivity of the medium, and multiplied by q1 q2 upon r square. So now let's move on to the questions. So it is a polythene piece rubbed with wool is found to have a negative charge of 3 multiplied by 10 raised to minus 7 Coulomb. Estimate the number of electrons transferred from wool to polythene. The options are given. So here we have to find the number of electrons transferred. So we have the equation that is from the quantization of the charges, that is Q equal to Ne. So from this we can find out the number of electrons, that is N equal to Q by E, that is total charge divided by the elementary charge, that is E. And here the charge is given as 3 multiplied by 10 raised to minus 7, so and it is negative charge, so charge Q will be equal to minus 3 multiplied by 10 raised to minus 7 Coulomb, right? And also we have the E, that is electrons are transferred here, so E will be equal to minus 1.6, the negative charge of electron, right? Minus 1.6 multiplied by 10 raised to minus 31, minus 19 Coulomb. And so we can find out the N as simply putting the values in this equation, that is minus 3 multiplied by 10 raised to minus 7 Coulomb divided by minus 1.6 multiplied by 10 raised to minus 19 Coulomb. So by dividing, the answer comes out to be 1.8 multiplied by 10 raised to 12. So this is the answer. Option B is the right answer, option B. Two conductors identical in shape and size, but one of silver and the other of aluminum, which is less conducting, are both placed in an identical electric field. In which metal will more charge be induced? Option A, induced charge will be equal. Option B, induced charge will not be equal. Option C, may be equal or may not be equal. Option D, none of the above. So from this question, we are going to figure out a fact related to induction on conductors. And so we have, in case of induction, the maximum induced charge is given by the equation Q dash, that will be equal to minus Q multiplied by 1 minus 1 by K. K here is the dielectric constant, and we know that the dielectric constant of conductor will be equal to, for conductor, okay, for conductor will be equal to infinity. So the induced charge Q dash will be equal to minus Q multiplied by 1 minus 1 by K in infinity instead of K. Okay, and so the final answer will be the same, that is minus Q. So that is, in both the metals, induced charge will be equal. However, in case of conduction, the current in silver will be more than in aluminum, as it is more conducting than aluminum. But here the induced charge will be equal. So option A is right answer. So next question, problem a charge Q is divided into two parts and then they are placed at a fixed distance. The force between the two charges is always maximum when the charges are options are given. So let's assume the two charges B, when split into two parts, Q and Q minus Q, okay. So the force will be equal to 1 by 4 pi epsilon 0 or K multiplied by Q of Q minus Q divided by R square, and I am writing here the K by R square as A. It is simply a constant, okay, because it is a place at fixed distance. So A multiplied by Q into Q minus Q. So we know that, or it is a fact that the force will be maximum when df by dq equal to 0. That is, the derivative of the force with respect to the charge will be equal to 0. Then the force will be maximum. So taking the derivative of this equation or force, we get d by here it is asked to find the charges when the force is maximum, right? So df by dq must be equal to 0. That is d by dq of A multiplied by Q into Q minus Q, that is equal to d by dq of A multiplied by Q minus Q square, that will be equal to 0, right? And so the derivative comes out to be A multiplied by Q minus 2q, and that is equal to 0. And here we know that A is a constant, so it cannot be 0. So the 0 term will be Q minus 2q. So equating that with the 0, that is Q minus 2q, which is equal to 0. So we get the Q as, or Q will be equal to 2q. So that small charge which is splitted from the biggest, or the total charge, that will be equal to Q by 2, capital Q by 2. Hence the two charges are Q by 2 and Q minus Q by 2, Q minus Q by 2 or Q minus Q by 2 will be equal to Q by 2. That is Q by 2 and Q by 2, So the correct option is option A. And when it's that is the we got the fact that when a charge is divided into two equal parts, then the force between them is always maximum. That's the fact we got from this question. And the next question: two equally charged identical metal spheres A and B repel each other with a force of 2 multiplied by 10 raised to minus 5 Newton. Another identical uncharged sphere C is touched with B and then placed at the midpoint between A and B. What is the net electric force on C? Options are given. So, two equally charged, not that two equally charged and identical metal spheres. So, let initially the charge on each sphere be small q, and the separation between them, that is we can draw like this, and at the A and B, two equal charges are placed, that is of the same charge, that is q, and distance between them is uh, is r is r let that be r. And so then according to the given problem, F will be equal to, now the force will be equal to at this position or at this situation, the force will be equal to 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, and q square, that is q multiplied by q, q square divided by r square. And that force is given as 2 multiplied by 10 raised to minus 5, that is 2 into 10 raised to minus 5 Newton. And in the next situation is another identical uncharged sphere C is touched with B and then placed at the midpoint between A and B. So when I can draw the picture like this, there are three spheres A and B. In the middle of them there is another sphere, that is C, and the A is having the charge Q, then it will be C and B. We have to find the charge. When the sphere C touches the B, the charge of B, that is Q, will distribute equally on B and C, equally on B and C, because the both the spheres are identical conductors. That is, now the charge will be, that is QB will be equal to QB will be equal to QC. QB will be equal to QC, that is Q by 2. That is Q by 2. And we can write it here, Q by 2 and Q by 2. And distance will be R by 2, because it is in the middle, R by 2. And this is also R by 2. And now, so the sphere C will experience both the forces from A and B, and from the A it will be FCA. FCA is equal to 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 multiplied by Q of Q by 2, Q and Q by 2. Q by 2 is the charge of C, and divided by the distance is R by 2, R by 2 the whole square. So we get R square by 4, and by cutting we will get answer as 1 by 4 pi epsilon 0 multiplied by 2 q square by r square, that is equal to the initial force, that is F, the 2 times the initial force, that is 2F, 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 and FCB, that is the force on C due to the metal sphere B. And we have to know that the direction of the force, the direction of this force will be along AB, right, towards AB, because it is a repulsive force, because they have the same charge. And so FCB will be equal to 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 uh, both the charges have the same value, that is q by 2 multiplied by q by 2 okay, sorry, q by 2 multiplied by q by 2, and the whole divided by the distance, that is r by 2 the whole square, and this will be equal to, simply that is equal to f. We get f, that is 1 by 4 pi epsilon 0 q square by r square. So the net charge or net force acting on C will be equal to fc, that is equal to FCA minus, FCA will be the highest force because the charge, it has more charge. So FCA minus FCA minus FCB, that is 2F minus 2F minus F, 2F minus F, that is equal to F, and the value of F equal to the given value, that is 2 multiplied by 10 raised to minus 5, 2 multiplied by 10 raised to minus 5. So that was the answer. So the answer is 2 multiplied, option C, that is 2 multiplied by 10 raised to minus 5. So the next question is given here. A pitch ball A of mass 9 multiplied by 10 raised to minus 5 kilogram carries a charge of 5 microcoulomb. What must be the magnitude and sign of the charge on a pitch ball B held 2 cm directly above the pitch ball A, such that the pitch ball A remains stationary? Here the situation is like, a pitch ball A is placed here and another pitch ball B is directly placed above that, is placed directly above pitch ball A, and the distance between them is given as 2 cm, and the question is, what must be the magnitude and sign of the charge on pitch ball B held 2 cm directly above the pitch ball A, such that the pitch ball A remains stationary? So here we know that for a pitch ball having a mass, a definite mass of 9 multiplied by 10 raised to minus 5, the weight will act downwards. That is, if the mass of pitch ball A is given as m1, then m1g, that is the weight of the pitch ball A, will act downwards. So in order to stay that A at the stationary position, so some force must act upwards. That force must be given by the force of attraction between A and B. So the nature of the charges of A and B must be opposite. If the charge on A is q1 and the charge on B is q2, and the distance between them is 2 cm, so that is the force between this must be equal to the gravitation of the weight of the pitch ball A. That is, we can equate this force between A and B, that is FAB must be equal to m1g, that is FAB must be equal to m1g, that is FAB can be found out by the equation 1 by 4 pi epsilon 0 or k q1 q2 by r square, that is equal to m1g. We need to find the q2, that is q2 is the charge of the B, and q2 can be simply found out by q2 equal to m1g r square by m1g r square multiplied by 4 pi epsilon 0 divided by q1. The values are given here. The m1 is 9 multiplied by 10 raised to minus 5. This is the mass of the pitch ball A, and G must be taken as 9.8, and also you can do it by taking the value 10, and R is given 2 cm. 2 cm will be equal to 0.02 centimeter. and the Q1 is given, that is 5 microcoulomb. Q1 equal to 5 microcoulomb, that is 5 multiplied by 10 raised to minus 6 coulomb. And giving those values in this equation, that is 9 multiplied by 10 raised to minus 5 and G 9.8, or take it as 10, that's all right. And the R is 0.02, 0.02 to whole square. We can for simplicity we can write it as 2 multiplied by 10 raised to minus 2, so we will get to 2 square, that is 4 multiplied by 10 raised to minus 4, that's all right, it's your wish. And 4 pi epsilon 0 value, 4 pi, 1 by 4 pi epsilon 0 is 9 multiplied by 10 raised to 10 raised to 9, so that will be equal to 1 by 9 into 10 raised to 9, and that divided by Q1 is 5 into 10 raised to minus 6, 5 into 10 raised to minus 6. So by doing, the answer comes out to be 7.84 multiplied by 10 raised to minus 12 coulomb. That's also that answer is somewhat, or it is similar to the option D. So option D is the right answer. And to know more about the cloud vendor, visit our website. You can Google by typing cloud vendor Gaurish. Site appears as the first result, and or simply search cloud vendor and you will get the site as the third result. And also you can follow us on different social media platforms, and you can follow us on Instagram, and you can follow on WhatsApp. I have created a WhatsApp group for discussions on different doubts you have, and the links are given in the description box. Also a Telegram group for discussion and the same purpose, and a channel is also formed for giving off your learning steps, and all the links are given in the description box. You can check it later. You can also ask your doubts as comments in YouTube, and if you want more videos which would be uploaded in the coming days, please subscribe our channel and press that bell icon for getting notifications on time.
Hope you guys understood the topic. Thanks for watching my video. Always be free to ask questions. Subscribe to my channel for more videos. If you like this video, share it with your friends. See you guys.